So hey guys, welcome back to my channel. Hope you're doing extremely well, and this is your very own mask coder this side. So today's question is kth element of two arrays, and it is a fabulous question. So I request you sincerely to please stay with me until the end. Okay, so what does the question say? The question says that you have two arrays. You have array A, you have array B. Both the arrays are sorted. Both the arrays are sorted. First point, the two arrays are sorted, right? Now, the question says that if you merge them such that the resulting array is also sorted, that is, array A is sorted, array B is sorted, and if you merge them such that the resulting array is also sorted, then what is the element on the fifth position, on the kth position, right? That is, if I merge them, that is, if I say A plus B equals to C, which is equals to, if I try to merge it sortingly, then I can say that it would look something like 1, 4, 5, 7, 8, 10, 11, 12, 15, 17. What I have done, I have said A concatenated with B, right? This will give me uh, A plus B, that is 1, 4, 8, 10, 12, 5, 7, 11, 15, 17. And then sort the A. This will give me this array, right? Now, if I see this is my first element, this is my second element, this is my third element, this is my fourth element, and this is my fifth element. So my answer requires 8 as my answer. My answer says that I have to return 8 as my answer. That 8 is the fifth element because k is given to me as fifth. So I hope the problem statement is clear to you. Okay, we will start from the brute force and move until we approach to the optimized version. What is a brute force approach? The brute force approach, not only here, the brute force approach is do whatever the question says. The question says to concat, to sort, and then to return. Do as it says. That is, make a like you have a vector A for auto it in B, A dot push back it. This particular loop will give A plus B. Then sort A. This will sort the whole composition. Now, as you can see, the indexes are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the positions are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is, for position 1 we have to return 0 index. Position 2 we have to return first index. Position 3 we have to return second index. That is k minus 1 index. That means I am saying return a of, this is a simple bracket, a of k minus 1. As simple as that, right? This is my brute force. What is actually happening? We are taking O of n space here, time complexity here, O of n log n time complexity here, and O of 1 time complexity here, right? So overall, it is O of n log n. In the maximum time goes in sorting, and the extra spaces, because with the B we are also attaching here. That means we require a size of additional B, right? So we are using extra space also. Let us say the size of A is n, and let us say the size of B is m, right? And capital N is equals to n plus m. So this all will be, this will be O of m, this will be O of capital N log n, right? Now the space will be O of n, right? That means we are using O of n log n and O of m space, right? Now let us move to some efficient. Let us move to some efficient, right? Not optimized but efficient. Let me paste here. This was a problem statement, right? What I'm saying is, instead of merging using extra space, I'm saying do not use extra space. Do not use extra space. How? Okay. So our k is equals to 5 right now. We have k as 5, right? Where I'm saying this first element is gonna be either 1 or 5 because these are the smallest element. So I'm putting my pointer I here, I'm putting my pointer j here. I say while I is less than n, that is I does not oversee the boundaries of A, and j is less than m, that is j does not oversee the values of B, right? And k, what I'm trying to do is, I'm saying that if my AI is smaller than or equals to B of j, That means the first occurrence will be of the ath element. You can see that 1 is actually less than 5. The first position will be taken by 1 in the combination array, right? That means I can say I plus plus. Else j plus plus. And because we have given first position here, so I'm saying k plus k minus minus. So what is actually happening? This will start. This will start. My I is here. My j is here. First iteration will work. AI is less than bj. Yes. So I plus plus. I comes here, and k minus minus. K comes fourth. Right. That means I have put one here. Now, 4 is less than 5. Again, I plus plus. That is, I will come here. 4 will be put in here. I'm not putting it actually. I'm just telling you what I'm trying to think. This is a visualization tool, not actually using an extra space. Right? I comes here and k minus minus. 4 changes to 3. 5 is now less. That means j will come here. Again, k minus minus. 2. That is, I'm putting 5 virtually, right? Now, 7 is 8. 7 is less than 8. That is, j will come here. I am putting 7 here virtually, right? And k minus minus again. Now, again, 8 is less than 11. That is, I will come at this position and I will putting 8 here. I am putting 8 here, right? Now, what can I say is that I have done all the things. This is the first five elements that was there in the combination array also 1 4 5 7 8 in the same order. That means without using an extra space, I am trying able to, as soon as it converts to 0, okay, my loop stops, right? And I am able to see my I is at 10, I j is at 11. That means if at previous step I would have stopped my I here, then I would have simply returned the 8 value. I would have simply returned 8 value. So I can say k is greater than 1, and then you can just write if a of I is less than equals to b of j, return a of I, else return b of j. It is actually what I'm trying to do is, you have already solved some days ago merge to sorted arrays. This was a problem I have solved in my one of my recent videos. So this is what I have done, but I have not used a vector to store them. I have just used the pointers to know what position I am on currently, right? Because I only need the position, right? These were all the efficient approaches, but the optimized approach is one that I would like you to have attention, right? Let me paste the question here. Okay, so this is our question 1 4 8 10 12 5 7 11 15 17. We already know our answer is 8. 8 is our answer, right? 8 is our answer. Let us go how. Okay, so let me write it 1 4 8 10 12. Another array is 5 7 11 15 17. What I'm trying to say is that we have k equals to 5. That is, we need 5 position, fifth position element. That is first position, second position, third position, fourth position, fifth position, and the remaining ones, right? That is, 4 elements are coming before it in the ascending order of the combination. Now, these 4 elements are coming either from this or from this or from both, right? 4 elements can come whole from this, 4 elements can come whole from this, 4 elements can come by combination of both of these, right? Now, I am trying to do something called as binary search. I am trying to use binary search here. How? See, this is not pretty evident from the question statement only, but again, what I'm trying to say, sorted is present, search is present. Whenever these two things are present whole in only, I always think that can I use binary search? Okay, so let me try to use binary search here. What I'm trying to say that either elements are coming from A or the elements are coming from B or the elements are coming from both of them. Let us say, let me try all the possibilities of elements coming from A, right? What can happen is I have 5 elements. I'm talking about only these 4 elements because I'm bothered about these 4. I can say that A, B, I can contribute 0 elements, 1 element, 2 element, 3 element, 4 element. And for this respect, sorry, A, B, 0, 1, 2, 3, 4. For 0, B can contribute 4, 3, 2, 1, 0 respectively. This can be the configuration. This can be the configuration. I am going to play with that only. I am saying, I will keep my low here, I will keep my high here, right? I am saying 0, 1, 2, 3, 4. My mid will come here. I am saying that I am taking two elements from here and the remaining elements, two elements from 1 comma 1 from array A and the remaining elements from B. How many elements I am taking from B? Two elements. How? 4 minus 2 equals to 2. So two elements from here. So my first partition says that one A contributes 1 4, B contributes 5 7. That is the remaining elements are 8, 10, 12, 11, 15, 17. Is this a valid partition? Is this a valid partition? What I'm trying to say is that the left side element should be smaller than equals to right side elements. Then it is a valid partition. Then only I can say now that these four elements are shorter than all the elements mentioned on the right. And only then I can say that these elements are sort. This is a sorted partition only if these all the elements are shorter than all the elements present here. That is true. That is true here. So I can say that this is a valid partition. So I only need this element, which is the first element, which is shortest element. So what I'm trying to say is my L1 is this, my R1 is this, where the partition has occurred. My L2 is this, my R2 is this, where partition occurred in B. So I can just say if, now you try to compare. Because L1 and right one are from A only, so L1 is always gonna be less than equals to R1 and L2 is always gonna be less than equals to R2. So what do I need to check to validate if it is a valid partition? I just need to check if L1 is less than R2 and if L2 is less than R1. If both these conditions are met, then this partition is valid. Then this partition is valid, right? So I can just say if this happens, then my answer is amongst these values. It can be this value or it can be this value, the minimum of R1 and R2. As simple as that. As simple as that. And if this condition is not met, then I will carry out the divisions on my low and high so that I can get the value for perfect mid, perfect position for the elements coming from the array A, right? So let us now move to the code. I hope it is clear with you. Obviously time complexity is gonna be n log n. Sorry, not n log n, it is only gonna be log n for binary search. I hope the approach was clear to you, and let us move to the code now. Guys, so here is the coding section. Let us start with it. So int n equals to a dot size, m equals to b dot size, the sizes of the array respectively. I am just saying if n is greater than m, n is greater than m, that means my time complexity will be O of log n because I am operating on a. So I'm just saying to keep it minimized. To keep it minimized, I am only saying that let us start with ba so that I am talking about the lesser time complexity, right? So return kth element of b comma a comma a. This is just a simple tactic because you know the time complexity is gonna be O of log n because I'm operating on a. So because n is greater, I just want to take the smaller element, that is b, as the smaller size array. I will operate on O of log m, right? That is simple tactic. When you can skip it also. So int low was maximum of 0 comma k minus n and high equals to minimum of n comma k. I'm telling you why. So I can take 0 element from a, 1 element from b, 0 element from a, 1 element from a, 2 element from a, 3 element from a, 4 element from a. Now for respective, for 0 element I would require 4 elements from b. As you remember, for 0 elements I would require 4 elements from b. That is for k equals to 5, I was taking 4 elements from a in one configuration, 1 2 3 4. Now it might be possible that in b, if I am taking 0 elements from A, it might be possible that B does not contain 4 elements. B contains lesser elements. So I would take K minus M elements. I would take K minus M elements, maximum amongst these two, right? Now, simple binary search. While low is less than equals to high, calculate your mid one. So int mid one, this is for the partition of A. This is for the partition of A. So int mid one equals to low plus high by 2. Simple. Now respective to this mid one, int mid 2 equals to k minus mid 1, that is the number of elements from array b. Now I am taking four variables l1 r1 l2 r2. If my mid one equal to 0. That means L1 is not gonna lie inside it. So L1 is will I'm taking L1 as int min in that case. So L1 equals to int min. Else L1 equals to element on the array on the mid position, that is a mid one, right? Similarly, if mid one equals to n, that is it is outside the bounds, then R1 equals to int max, else R1 equals to ARR mid. Not ARR, it is ARR a mid one. Similarly for mid 2 and R1 R2 and whatever etc. So if mid 2 equal to 0, L2 equals to int min, else L2 equals to B mid 2 minus 1. It is minus 1 here. Sorry for my mistake. Yeah. If mid 2 equals to M, R2 equals to int max, else R2 equals to B mid 2. Right? We have assigned it. Now, if this is a valid partition, that is, if L1 is less than equals to R2 and L2 is less than equals to R1, you can return maximum of L1 comma L2. That is valid partition. So the maximum from the left partition, you can return it simply. Else, for the operation of low and high, if L1 is less than R2, if L1 is greater than R2, that means more elements are coming from A, it has to be lesser. More elements are coming from A, it has to be lesser. That means I will have to reduce my high. Only then it will be max lesser. So high equals to mid minus 1. Else, low equals to mid plus 1. It will be mid 1 minus 1 and it will be mid 1 plus 1. Right? As simple as that. For formality, return 0 here so that it does not give any error. Let us try to compile and run it. Running fine for the sample test case. It will run fine for the submission as well, I guess. Running and getting accepted. So thank you for watching. Hope you liked it and please make sure to like and subscribe to the channel. Thank you. Have a nice day.